Hi everyone, this is the Osquery workshop. Thanks for being here. I know I stand between beer, so I'll try to be quick, and it's a nice day out, so I know everyone wants to get out, but let's get through this. I mean, I can't win against beer and a nice day in Vancouver, so. But thanks to Matt, JD, Nick for organizing the conference. It's a lot of work, I know. So we are going to be extending Osquery by building extensions. I run a consultancy. I do a lot of agent systems development. I do Osquery development. I'm an Osquery developer, maintainer, what have you. Worked in engineering roles, and this is where you can catch me after. There are a couple of prereqs. I hope you paid attention in JD's workshop because now you know Osquery. But Git, anyone not familiar with Git? Cool. Anyone not familiar with running commands on a terminal? Awesome. Programming, anyone not okay with programming? If, else, for, you're there. And curiosity. I mean, you're all here. I don't have beer, I don't have stickers, so I'm assuming this is why you're here. The format of this is a little weird, and against Matt's advice, I'm doing like live coding. So there will be mistakes, but mistakes are part of the learning journey. And I want this to be collaborative, so ask questions, share insights, don't heckle though. And yeah, the goal is to build an Osquery extension. So why would we want to build it? Sometimes there are APIs that Apple has kept private. Sometimes we need to shell out to get the data we want. Sometimes we have internal resources that we are querying which we don't want public. And sometimes it's just faster and easier to build an extension and move on with our lives. So we'll use the excellent MacAdmin's Osquery repo. A couple of authors are already here in the room. I've posted links to some resources in the Discord, so check it out when you can. And we'll use, as an example, we'll use the background task management info in Apple's SFL tool. So anyone come across these before and kind of wondered what the context is, right? Like, I would really love to know some more information on this, but it's kind of hard to know. Well, Apple has that already in their tool called SFL tool, and the command is dump btm. And you know, this is kind of what's all running. So there's a lot more information, right? So I have supervisor, the identifier is monkey, I have one password, these are the identifiers. So this is behind private APIs. So we can't have a table in Osquery core, but this is very useful data. We would like to see this data in Osquery because a lot of malware persists and does things in the background, and it's kind of nice to keep an eye on that. So we'll come back to this output a little bit later, but I'm just gonna save this locally so we can, you know, come back to it. And we are going to use the Osquery extensions repo. So if you haven't done that previously, you can just kind of git clone your way and kind of, you know, do that. I already have a directory here. And the first part, the first challenge is kind of just building it locally. So there are a couple of dependencies. You need Go and you need Basilisk. So if you do brew install Go and brew install basilisk, it should be there, and you should be good to go. The only other thing you need to do is run make, and it will go ahead and build this extensions in the repo. So if we look at the build directory, you can see on Darwin there's like the Intel version and the ARM version. But let's make sure we can actually run this. So locally I'll bring up Osquery. I'm adding the verbose flags just for my own benefit, and I'm just specifying the extension here that we just built, specifying the ARM64 because I'm on an M1 Mac, and I'm gonna do allow unsafe because I haven't set the permissions correctly. And in a minute, the extension should connect and register, so there we go. So now we get all these awesome tables that are part of the MacAdmin's Osquery extension repo. And we can go ahead and kind of, make sure it's loaded so you can see this extension with this UID loaded. So that's great. So this is kind of the first challenge, and it's kind of nice to be able to, build things locally and get going. And the next thing I would like to do is kind of build a small Hello World extension on top of this, just so that I know the changes I make are okay to go. So in this Git repo, I'm just gonna create a new branch. MDOYVR, okay. And I'm gonna switch to my editor now. And there's a helpful README here, what all tables are there. So we want to add a new table, so I'm just going to create a new folder in this tables folder and call it, I don't know, BTM info. And in this folder, we need to create a couple of files. Oops. So we'll need, let's say, btminfo.go. I'll add it to get later, and we'll need build dot basal, and I'll add it to that later. So the build.basal is just like specifying what sources are there and what to do. So I'm just going to copy it from one of the other tables because that's programming sometimes. And it's kind of boring if I type all this. So let's do that here. Oops. And then, the name of this is BTM info. The source of this is btminfo.go. This is inside this import path. Visibility is public. We don't need the plist one as a dependency. We might need the utils one as a dependency. We definitely need the Osquery Go SDK plugin table as the dependency. So that's great, and let's write our hello world now. So we need a couple of things to import. We need context. That's just Go's context. We need the Osquery Go plugins, and I'll need the table plugin because that's what we're building. And we need two functions. So if we look at the SDK table, this is from the SDK, so we kind of need these column definitions and generate function. So we are just going to do that. Here, I'm going to define a couple of functions. Let's call it BTM info columns, and it returns a array or a slice of this type, column definition type. So we're just going to return and this is where we would like define our tables in Osquery. So you know, if you do anything with Osquery, let's say select star from Osquery info. These are the PID, the UID, the instance ID. These are the columns. So I want to go ahead and define those. And if we look at the BTM output, we'll take a closer look at this, but it looks like there's UUID, there's name, there's developer name. So let's pick one or two, and then we can build and iterate on it. So one column I want is name, so it's a type text because it's just string, and the other one I want is, let's say, UUID. I'm just gonna keep it as a string. And then I need a generate function, and this is the function that Osquery Go SDK calls, and this is kind of what returns the data in those tables. So let me go ahead and define that. And generate function takes two parameters, so there's the context, and it also takes Osquery context. So that's just, so query context contains, like when you do in Osquery select star from, and then you add predicates or filters like where column name equals this, limit this, order by this. That's the query context. We're not going to worry about it, but we need to pass in because that's the function signature. And the return type is a tuple. The first element is an array of a map from string to string, and the second is just an error. And that's what we're just gonna, you know, put our results here. So I'm just instantiating a map of string, and, you know, just gonna append whatever data we want here. And as is customary, so we define two column names here, name and UUID. So that's what we're gonna do. So name is hello, and UUID is world. And then we need to, you know, of course, return results and nil because our return type wants two things. It's a tuple. So this is a basic kind of hello world table. Let's go ahead and run this. So there are a couple of other things I need to do in the build system. So one of them is in the main Bazel build system. Like we need to kind of add our entry here as a dependency. So it's BTM info, and in main, we need to register as a new plugin. So you can see all these are already registered here. So I'm just gonna, you know, add one entry here. It's a new plugin. The name is BTM info, and here's where we pass in those columns and the generator function that we defined. So these are the columns, and we need the generate function. So there we go, and we can now build this, and hopefully it will compile.
Question for you.
Sure.
So would you consider this to be like setting up your ORM and your database migrator for this project?
I don't think ORM kind of maps.
Repeat the question, Sharvil.
So the question is this similar to, creating an ORM and a migrator? This is more setting up the schema. The ORM kind of doesn't translate because these are all virtual tables, and there's no kind of data behind it, right? When you query it, whatever in the generate function gets run. So, if it's calling a system API, it's going to result that output. If you're just returning hello world, it's going to return that. So there's no kind of data store. Does that?
Like a real database?
Yeah.
Okay.
Yeah. So these are virtual tables. So even with Osquery, there's no database per se, like a traditional SQL database. We are just using SQL layers and virtual table interfaces to kind of give you an illusion of the database. So it looks like we didn't have any compilers, which is good. Let's go ahead and run this and see if our table showed up. So we see our table plugin got registered called BTM info. Let's go ahead and query it. And ideally, the output should be hello as the name and world as the UUID. And there we have it. So this is super simple to kind of, this is just hello world. I know you're all excited for beer, but please bear with me. So it is very simple to add new functionality and to extend it. And now we kind of, move towards our goal of getting the BTM data. So when I'm faced with doing this, I kind of ask myself how does Apple implement it? How did Apple implement it? So the way I start by doing that is just reading the man page, because Apple's great at documentation, right? Yeah, so this doesn't give us much, but this was built in 2012, okay. This thing called archive, okay. This is the executable, okay. And if we just run SFL tool, there's archive, but there are all these other, so the documentation, in this case, not that helpful. And sometimes these executables masquerade as Python scripts or what have you. So the next thing, I kind of want to just make sure what kind of file we are dealing with, so I'll use the file command. And here we can see that it's a Mako universal binary with two architectures, x86 and ARM64. So it's not a simple Python script. Any questions so far? Have I lost everyone? No? Okay, so now we have a little bit more info about this tool. The next thing I kind of want to do is figure out what other system libraries it's using. So the way I do that is use OTool, which is just a way to display Mako object tools, and I pass in the L, which is show me all the shared libraries that's linked against this executable. So let's do that. And here we can see right away that there is a system library private framework called background task management. And core services, foundation, security, libarchive, ncurses, okay. C++, Objective-C. So this kind of gives us a little bit of idea of what this tool is, and we can run this with Osquery as well and figure out. So if you want to figure out what libraries Osquery links against, we can, do that. And yeah, so it links again system B, lib endpoint security, BSM, archive, C++, security, but no private frameworks as expected because Osquery doesn't link against any private frameworks. And even if, let's say with SFL tool, we figured out the private framework and the APIs, it's sometimes not just as simple as linking and calling those methods. So in this case, the next I'll check for is like entitlements. And in this case, we can see that it's protected behind these two Apple private entitlements. What this means is even if we can hook into those and call those methods that this SFL tool is using, our code won't run because we don't have those entitlements, and Apple will never give a private developer these private entitlements. So entitlements are basically Apple's way of doing declarative capabilities. They are kind of meshed together with your code signing certificate. So this is also a no-go. So the other kind of ways to look at like how SFL tool gets all that data is another system tool called NM. This just gives you names and symbols that are in the binary. This kind of sometimes gives you an idea of how this tool is implemented. So I'm going to use that, and I'm going to pass in the -G. That's for global symbols. So this is basically, kind of spying on SFL tool, not really, but kind of. And we can see this method names and constants that it's using. So we kind of sometimes get an idea of like how Apple has done this. And this kind of gives it away that it's on Objective-C, coded in Objective-C. But there's nothing much to go on here, but sometimes it's just nice to check this. And the other kind of way to do that is use ESLogger and spy on it. So ESLogger is Apple's own endpoint security tool. So I'll need kind of two terminals here. So I'm just going to call ESLogger, and I want all exec and open syscalls, and I want to save that as ESLog.json. Oh, I misspelled open. And while that's going, we'll need to run, our SFL tool. So this basically captures all exec and open calls, but this might be like a huge file, and you just have to like slog through and kind of take a look around. So yeah, so in just that's a lot of data, and it's not always fun, but if you kind of want to reverse engineer things, you just have to stare at the wall. And let me try and reformat this a little bit so it's easier to read. And let's search for SFL tool. So yep, I ran it with sudo. These are the arguments. Yep, that's my teletype terminal. All the data that I currently don't care about, but it's a lot. Okay, so there's a event open on Cryptex's OS, whatever, and sometimes you can like figure out like, oh, it's reading, a file from PrivateVAR DB, and sometimes it's just returning data from cache, so it's not always the case that you'll capture that open event. But if you do this multiple times, you'll get a hit on it. But I know that the way SFL tool works is it has a plist with all things Apple. So the plist is in VARDB, I think. So I'm just gonna copy that here. Okay, and if I do like a file on background items great, Apple binary property list. So great, like we know how to read plist, we know how to read JSON, we don't have to parse this output, right? We can just read the plist. Let's convert that plist. So I'm just gonna change the ownership of it so that I don't have to type sudo anymore. Okay. So the way we convert it is by using plutil, right? We just pass in the convert. We want it in an XML format. Great. We should have all the data, right? Let's take a look. Unfortunately, all the data is serialized with NSKeyed archiver, which is like if you do Python, it's like pickled files. And if you do Objective-C, this is very common. And it's kind of garbage and useless and not really helpful. So unfortunately, we will have to parse that whole stream of text. And I think now we kind of have a way forward of how we're going to build that extension. Questions? Am I losing people? Too fast, too slow? Yep.
Have you considered setting up Touch ID for sudo?
Repeat the question, the smart Al.
Have you considered setting up Touch ID for sudo? No, I have not.
Do it live.
Usually, my Mac is connected to a monitor and external keyboard, which doesn't have Touch ID. All right, so we have made some progress. We have returned a Hello World extension. We kind of figured out how Apple might have built SFL tool dump BTM. Oh, there are other kind of ways to kind of poke around it, but that requires disabling SIP. So if I was very motivated, I would disable SIP, pull up SFL tool in LLDB, put breakpoints, and kind of work my way around it, but I'm not going to do that right now. So let's go ahead and kind of take a look at the output we have from BTM and kind of like analyze the structure of it a little bit. So what jumps out here is that it's recording things per UID. So it's a little bit of a nested structure. Also, anyone seen a UID -2 before? No? Okay. It's a legitimate thing. It's Apple's kind of way of telling you it's a unprivileged user. But I didn't know about negative UIDs until now. Osquery actually shows that data. The column is signed UID in the users table. Anyhow, so it's a little bit of a nested structure. So we have records per UID, and inside of this, like records for this, there are a bunch of items. And thankfully, it's like, numbered for us. Let's see if we can find another records for Yep, so there we go, records for UID 0. I think we all know what UID 0 is. And here's another one, UID 501. Great, so we just need to parse this, right? Simple. So this kind of gives us an idea of how we'll structure our code. And this might be a little bit tedious watching me kind of type code, but we are more than halfway there. So I kind of want to track records and items. So I'm going to just create like a structure. This is kind of like defining your own types. And if we take a look at this, I'm just going to worry about name and UID for the item right now. So I want name, and that's going to be a string. I want a UID, and that's also going to be a string. And the other kind of type I want is the record type, so I can call it just BTM record. And it has a UID, which is a number, but I'm just going to go with string because it makes things easier for parsing. And the other thing it has is a list of these items. So I'm just going to define that, and that is an array of the item. So now we'll need to update our generator code. So the idea is we'll shell out, call SFL tool BTM, capture the standard output, and then parse the standard output and return these things. So it's simple, it's just tedious, but we'll get through it. So the way to kind of shell out is using exec. So, my command is basically and I'm just going to give in the path to our SFL tool, and the argument is just dump BTM. Right? So I'm just creating an exec command type here. And what I want is standard out and error, because this is Go. And I want like a standard out pipe. And I'll need to, check for error not equal to nil. If it's nil, just return nil and error. And now I need to start this command. So the way to do it is, again, because it will return an error if there's an error. So the way to do that is, command.start, and command.start returns an error, and we need to check if it's nil or not. And then, just return nil and error. And here I have a spelling error. Okay. So now we have standard output of this error. So I want to parse that. So I'm just going to say something like, out, and I'll define a function called parse records, and I'll just pass in standard out. And I'll create a new function here to do our parsing. And standard out is of type IO reader. So I'm just going to pass that in. And this will return an array of records because that's what we want. So that's what my return type is. Doing good so far? Yep. Cool. And since I'm not going to call out here, I'm just going to like do underscore so that the compiler is happy. And kind of the next step is, I need a variable to hold these records. This is the one that will return. And we have standard out, so I want to use a scanner to kind of take that in line by line and parse it. So I'm just going to define a scanner. I think it's in buffered IO. Yep, and I'm just going to pass in standard out. And I'm going to iterate over this iterator. And, just grab the first line. So that's just scanner.text. And right now I just want to print that line just to make sure we are making progress and code compiles. So I'm just going to do that. And we need to return records here. Okay, so ideally this should compile. And when we link it with Osquery and run select star from BTM info, we'll still get the hello world because that's what we are kind of returning here. But before that, it should kind of print all this standard out line by line. So let's go ahead and do that, make sure things work up until now. So we run make, let it do its thing. Maybe I should do touch ID with sudo.
Do it live.
Okay. So there is an error somewhere.
It's further down. It's at the bottom. 20 equals
Where? I don't see it.
42.
Is it on line 42?
No new line on the left of the.
Yeah, so thank you. Just need an equals, yeah. Okay, now it should compile. So this is fun of doing it live. You are all here to help me out. And mistakes are part of the process. Cool. Let's see if we can link this and do select star from BTM info, and does it print? I'm just gonna have my configuration running, so I had to wait a few seconds. We see BTM info got registered, and just do that. So it works. We still have hello world because we didn't change that, but we have all the standard output here. So making progress. Any questions so far? No? Too hard, too easy? So now is kind of the tedious part of, doing all this parsing. So let's update our parse records function here. And along with this records, I also want to keep track of the current record that we are working with. So that's just going to be a pointer to our BTM record struct. And I also want current item. And similarly, that's just going to be BTM item. And let's take a look at this output here to kind of figure out how we'll do this. So most of the stuff has a colon here, so kind of makes it easy. We split by colon, take the left as a key, take the right as a value. So that's straightforward. We have these things that we don't care about. There's a colon here, which we can grab this UID and, EUID here. There's colons here too, which I don't care about, so I might have to just pass over those lines. So let's go ahead and start parsing then. So we have the line here, and let's start with, here we had, let's look for this, records for UID, right? We'll do a prefix on that. So if, strings dot has prefix on this line, and I want records for UID. And here we have to be careful a little bit. So, we have to do, if our current record is not nil, because if it's, then, we have to kind of create a new one. If it's not nil, then we just kind of append it to the records. And that takes in records and pointer to the current record. And then we'll kind of instantiate this current record, and so current record takes in UID and the list. So we'll kind of just do UID for now. So the UID field is just this line, and what I'm going to do is just split by colon and just take that part, figure out this a little later. So I'm going to also trim space on that, and then I'm going to split that line we have, and line, and we want to split by a colon. And what we want is the second part, so the first element, not the 0th element. Right, and I need that, okay. And I need to continue this. So took care of that line, and now the lines are, don't care about this one. This has a colon in it, so I'm going to have a special case out and then just kind of continue over it. So let's just do that. I'm just going to copy this. And we'll have another similar if clause here, if strings dot has prefix on the line, and the prefix is this thing, just ignore that, continue. And similarly for the second one here, I'm gonna do that as well. And again, I don't really care about this, so let's just pass that over. There are multiple ways to parse things. regex is there, but I don't want to do that live, so we are doing this the tedious way. And now if we take a look at that, our output, we have this line starting with this hash or the pound key, and then we have these, kind of nice things separated by a colon. So we're just gonna do that. So let's do if strings has prefix, and we want that hash key. And now what do we want? So we need to make sure, now we're getting into the items bit, so we kind of want to make sure that the item is not nil and the record's not nil. So let's kind of add those guards here, because otherwise it might complain. And if they're not nil, then, you know, on the current records BTM item field, current record, yep, we called it BTM item, okay. I just want to append our current record dot BTM item and point it to our current item. Right, and we need to instantiate current item, and since that's just, and not gonna worry about its field, we'll kind of do that later. This is, sorry, BTM item, that's right. And we wanna continue. Right, so that's the prefix line, and then that's this line, and now we kind of get into this thing. So here, I'm just gonna do if string contains this thing. We pass in the line, we pass in our colon. Sorry, this is a little tedious, but almost done. And we wanna split this up in parts, so I'll have a parts thing, and I'll just use a split n method with line, with a colon. And what this does, this will be like at most 2, because that's what I want. If there's a colon here or whatever, I just want 2 things, and kind of, that's the assumption I'm making. And now we can kind of split this up as key and value, key and value. So let's define key as, you know, parts of 0, and I'm just gonna trim the space, and then value is gonna be same thing, but parts of 1, right? And then, you know, we just do a switch thing. So if the current item is not equal to nil, we want to switch on key, and case is UUID. And if it's UUID, we just update the current item dot UUID to the value. If the case is name, we just update the current item dot name to the value. Okay, and so let's start with this. Let's see how it goes, and we just need to append the last 2 items here. So I'm just gonna do that. If, you know, current item is not nil, I want to append it inside the BTM item array, and current record dot BTM item array, and yep, current item. And similarly, if the current record is not nil, I want to append it to the records thing that we're going to return. And right, so hopefully this made sense. It's just doing the grunt work and just kind of making sure things are not nil. But we do need to kind of update our generator function. So this will call the standard out, pass it to parse records, and then collect all this data from parse records and return it. So let's do records. And then, we need to iterate over records. So I'm going to use a range-based iterator here. And it's kind of a nested structure, so we'll need another for loop to iterate over the items inside this record. So let's go ahead and do that. This underscore is just, I don't care about the index. And item, this should be record. And the range is, records dot BTM item. Record dot, thank you. Naming is important. And we already have this results map, so I'm just gonna update that. This should be result, and it's a map of string, and the name is item dot name, right? So this name is this column here. And then what else do we want? UUID, UUID, that is just item dot UID, and UID, this should be record dot UID, and I think we'll also need to add a new table here called UID, or column here. Right, and we need to, results is append results and result. And okay, this is out of scope here. Okay, there we go. And this is left over from previous, so let's kind of do that. Let's get back to building this. And let's link our newly built extension. And let's see what we get. Nothing, wow. So live debugging, that's fun. So I'm just gonna print this printf, and Is it %v? I think so. Let's go ahead and build this again. Oh, yeah. Okay, there are things there. But so we have parse records, that gets us the records. Sorry? I can't hear who is saying.
Maybe that got populated into them.
What's populated?
Maybe like maybe the scan function didn't actually succeed in.
That is true. It could have kind of some error here maybe. Yeah. Okay, but this is kind of like how we'll go about doing it. Thankfully, I have a working version in another branch. So, so I'm just gonna make clean, git stash everything here.
See, you were just torturing us.
Sorry. And git checkout. Okay, I'm just gonna remove. Stash should work, right?
If you stage the files.
Oh, I need to stage it, that's true. So I need to add all of them, right? Yeah. And now I'm gonna cool. I'm gonna make clean and to make, and hopefully this will work. Not there yet, not there yet. I know everyone's excited for beer. Okay. There we go. So, you know, I picked a couple of fields and all the data that we have from BTM, we have it here. Let's just go ahead and count these. So 110. Let's go back to our Scratch file here. Let's count how many these are. So for UID -2, $43. For UID 0 is 18 and 49. So 43, 49, 18, 110. So we have all the data. And yeah, so this is kind of how you write an extension in Go and extend Osquery. You kind of take Apple's internal tools or APIs and extend it and get the data you want. The live coding didn't really go as well. I'm sure there's a bug. There are always bugs. And that's kind of my workshop. I have posted some resources in the Discord channel. I'll be there. I'll be on Slack. Hit me up, ask questions. Questions, comments, criticisms, concerns, CVEs.
Do you do a lot of reverse engineering when you're doing stuff like this?
I used
Do you need a microphone, sir?
I don't know, you tell me.
Do you do a lot of reverse engineering when you're doing stuff like this?
Yeah, I do. And I used to do that a lot, but lately it's getting harder and harder to reverse engineer Apple binaries, Apple stuff. Oh, that reminds me, there's one tool which would be kind of cool to show you, since this is return in Objective-C, the SFL tool. So previously you could run class dump and get kind of methods and all that. Now you kind of have similar on Apple Silicon chip. There's a very nice tool called IPSW, and I'm just going to run class dump on our SFL tool, and it's just asking me what architecture I want. I want ARM64, and it kind of nicely lists all the interface and classes and methods and messages. So yeah, I do a little bit of reverse engineering. I'm not great at it, and Apple is making it harder and harder.
I think we had another question here.
So are you still shelling out here? So you're
Yeah.
still, so we ended up not using the libraries because we weren't allowed because of the.
Even if we could, so that's the point I made, like even if we kind of linked into that libraries, SFL tool is protected by these private entitlements. So even if we could and compile it, when we run it,
Right.
Amphi and Gatekeeper are say, you know, this requires an entitlement, you don't have it, and your process is gonna get killed.
So how would you handle if this was like a long-running shell command? How would you handle something like that?
So that's kind of the nice thing about Go. I'll like put it on a background Go routine, set a timer or timeout, and then kind of, you know, call back to it and see if it completed or not. But that's also not the use case you should be using to shelling out, like for long-running things. Yeah.
Maybe you can give a quick talk, you know, the nice things about Go, right? It's a short talk.
I am far from the Go expert. There are so many people here, Zach, Graham, others that I haven't met yet.
Yes. Let's do it. You just nerd sniped them all. Okay. Thank you, Sharvil. That was amazing.
Thank you.